This is Mr. Anderson for Kellogg Community College. In our second video today to review the test for chapters 3 and 4 in intermediate algebra, we're going to be focusing today on inequalities and graphing and set notation and interval notation. So we'll start off today by solving a little easy equation for x here by using inverse operations. We're going to get x by itself. So we add 5 to both sides, so 2x is greater than or equal to 14. Then we divide both sides by 2, and x is greater than or equal to 7. Now what we're going to do here is then plot this on the graph. We'll start our number line at 7, and since this is greater than or equal to, this will be a bracket, and we'll have the arrow go to the right. And that right there shows that x is greater than or equal to 7. Since this is going to positive infinity, our interval notation is going to be the bracket at 7, sorry about that, comma, positive infinity with a parenthesis. Infinities always have parentheses since we're never actually getting there. The set notation is going to be like our answer over here to our problem, where x is going to be greater than or equal to 7. There's our set notation. In problem 10, it's very similar to problem number 9, except that we're going to do a little bit more work to get our x by itself. Subtract the 9x from both sides. And so what we have here is we have a negative 5x plus 7 is greater than or equal to negative 3. We're going to then subtract the 7 from both sides. And so what we have here is negative 5x is greater than or equal to negative 10. Dividing both sides by negative 5, x is less than or equal to 2. And the reason why we flip the symbols, we divide it by a negative. So this is going to be another bracket since it's less than or equal to, starting at 2 and going to the left because of the less than. The interval notation is going to go from negative infinity to positive 2, so make sure you have your negative infinity on the left because interval notation is written from lowest to highest. So negative infinity, sorry that looks so bad there, and 2 with a bracket. The set notation is going to be the set of x so that x is less than or equal to 2. Alright, there we go. There's our first two problems. Let's go move down the screen here a little bit for the next two. There'll be a lot more room to draw on your worksheet here, but this is an easy way to fit all of this on one side here. Now, as we do more solving for x, we're going to first of all distribute this to these two places. So we got 4x plus 7 is greater than or equal to 14x minus 42. Then we're going to move the 14 over to this side here, so subtract the 14x from both sides. And that gives me a negative 10x plus 7 is greater than or equal to negative 42. Now what this is going to do, I'm going to subtract the 7 from both sides. Negative 10x is greater than or equal to negative 49. Divide both sides by negative 10. And I have x is greater than or equal to, well, you can have 4 and 9/10 or 49/10. Let's do 4 and 9/10 here. Alright, 9/10. Sorry, that looks a little weird there. What I did not do when I did this problem is after you divide by negative 10, you have to flip the symbol. So be aware that this symbol has to be flipped there. So it's less than or equal to instead of greater than or equal to. So my 4 and 9/10 or 49/10 is going to be here with a bracket going to the left and shade to the left. So we will flip the symbol when we multiply or divide by a negative. And in this case, we're just like problem number 11, we're going to do some more distribution here. And this is going to be 5x minus 15 plus 4x is greater than or equal to 14 plus 4x. We're going to simplify our x's over here. We got 9x minus 15, that's combining like terms. And over here, I'm just going to change the order using the commutative property, just because I want my x's on the left and my numbers on the right. Subtract my 4x from both sides, and the 4x's go away there. They simplify to 0. And this is 5x minus 15 is greater than or equal to 14. Add 15 to both sides. So 5x is greater than or equal to 29. Divide both sides by 5. I'm not going to flip the symbol here. My answer is going to be x is greater than or equal to 29/5, which is the same thing as 5 4/9. Now this is going to be a bracket. All of these are brackets, but please be aware that if this was not greater than or equal to, this would be a parenthesis, like a greater than sign. So this is going to be 5 4/9. And it's going to go shade to the right. Alright, now you'll notice that I left off my interval and set notation. We can always go back and do that later. The interval notation is going to be from -infinity to 4 9/10. So here's my parenthesis going from -infinity to 4 9/10 using a bracket. The set notation is going to be where x is going to be less than or equal to 4 9/10 or 49/10. And the interval notation here, you can look up here at the screen, and this is going to go from 29/5 or 5 4/9 all the way to infinity. So my interval notation starts with a bracket, 5 4/9, and goes to, whoops, I don't know, that actually got, sorry about that, comma, infinity. I'm going to go rewrite that again just because my pen slipped there and created that little edge. There we go. That looks a lot better. Now the set notation is going to be where x is greater than or equal to 5 4/9. Alright, let's go take a look at the next section here. Let's go to the next page. Alright, we got some problems for intersections and unions. Alright, so let's go take a look here. What we got is, let's see, we're going to take the union of these sets. Now the union of this group here is going to be all of the numbers in both sets. So this is going to be the set of 2, 4, 8, 9, and 10. So that's the union of all of these. Now the intersection of these two groups right here is going to be just 5. Because this is the only thing that they have in common. Even though these both had 8s in them in the union right there, that union, you don't have to write it twice. And if you write it twice, that will be a bad thing for the test. The set should be each element of the set, but no duplicates, please. Now, you'll notice that these two groups have nothing in common, so this has really nothing together because the intersection has no overlap. Now here, this is the union of 3, 5, 7, and nothing, which is 3, 5, and 7. And this is the intersection of these two groups, which is nothing again. Now what's interesting here, if I have the union of all numbers that are less than 5 and including 5, and the union of all numbers greater than 5 and including 5, my answer here is real, because I'm going to have every single number covered. Alright. Now my next problem is going to be solving for x, and the last part of this worksheet, this video here, is going to be talking about absolute values. So let's go take a look at these absolute value problems and see what I could have in store for myself here. Alright, so let's rock this out. What I'm going to do first is I'm going to try to get the absolute value all by itself. And in doing so, I need to move the 7 to the other side. We'll do that first. So I have 3 times the absolute value of 2x minus 5 is equal to 6. Then what I'm going to do is divide everything by 3 to get that 3 out away from the absolute value sign. So this is 2x minus 5 is equal to 2. Now, since I've got the absolute value all by itself here, I can now apply my rules for dealing with absolute values, which is write it like you see it and solve it, and write it like you see it and solve it, but make the opposite answer. Now we would flip the symbol, but since it's an equal sign, it looks the same either way. So I'm going to add 5 to both sides here. So 2x is equal to 7. Divide both sides by 2. X is equal to 3.5, or 7/2. That's one of our two answers. And I'm going to add 5 to both sides here, and that's going to make 2x is equal to 3, and then divide both sides by 2. X is equal to 3/2, or 1.5. And what this means is that my solution set here for x is going to be 1.5 and 3.5. If I really want to be fancy, just put it in the set notation here because this is a finite set. So these are my two answers. If I plug them in for x, it will give me an answer of -1. Now, what we're going to do when solving with absolute values, we have to talk about their intervals and their set notations. So let's go show you what we have here. We're going to take a look at, first of all, the first thing I've got to do is to move that 5 to the other side. So I have the absolute value of x minus 4 is going to be greater than negative. Oops, sorry, there's a typo in this. You need to change this to a 12 because the other way that I've set it up is going to be, it's always going to be all real numbers. So make sure this is a 12 before you start the problem. So we're going to add 5 to both sides, or subtract 5 from both sides, and if I go 12 minus 5, I get an answer of 7. So again, make sure that's a 12 and make sure that gets fixed. Now that I've written it that way, I'm going to write this as two separate equations, and since it's greater than, this is an OR equation. So I'm going to have x minus 4 is greater than 7, or x minus 4 is less than -7. So when I change the answer on the right hand side, I have to flip the symbol. So if I add 4 to both sides, I get x is greater than 11. If I add 4 to these both sides here, I get x is less than -3. -7 plus 4 is -3, and 7 plus 4 is 11. Now this is an OR problem, so generally speaking these OR problems will go away from each other. So if I graph this, it's going to go, I'm going to have a curved parenthesis going in this direction because x is going to be less than -3 to -infinity here. And this is going to be at 11, it's going to be a curve going to the right here to +infinity. So my interval notation is going to be two separate groups. I'm going to have a group that goes from -infinity to -3, or a group from 11 to +infinity. You may also use the union symbol between the two of these to represent them. The set notation is going to be what we have written up here, except I'm going to put the x is less than -3 in front, because -3 is less than +11. X is greater than 11. Okay, so there's my set notation. Now this problem number 16, boy, it's a workout right here, and this is an example that's going to turn out to be. Let's actually modify. Let's actually keep this the way it is right there. Let's now solve for the absolute value problem. So I'm going to add 2 to both sides. All right, I'm going to add 2. So this is the negative of 2x plus 4 is less than -4. Then I'm going to divide both sides by -1. So I get 2x plus 4 in absolute values. Signs there. And I have to flip the symbol there because I divided by -1. It's going to be equal to +4. Now this is going to be an OR equation again, which means that I don't have any AND equations to practice with you right now, so you may want to actually go to your book and see if there's a couple AND problems you want to practice. What we're going to do here is we're going to see that I've got 2x plus 4 is greater than 4, or 2x plus 4 is less than -4. So make sure you got to flip the symbol there. Subtract 4 from both sides. 2x is going to be greater than 0. Divide both sides by 2. X is greater than 0. Here I'm going to subtract 4 from both sides. So 2x is less than -8. Divide both sides by 2. X is less than -4. So I've got two equations going in opposite directions. I've got one equation right here that starts at -4 and goes to the left, like so. I've got another equation that starts here at 0 and goes to the right. And so my interval notation is going to be between -infinity and -4. Or, you can use the union symbol here if you'd like, you could go from 0 to +infinity. Like so. Alright, now again, I'm not giving you a practice problem here of an AND problem, so you may want to go back into your work and homework and do that a couple times. Just pick some problems out of the book, and you should be okay. My set notation is going to be where x is less than -4, or x is greater than or greater than just 0. Alright, now that finishes our second of 3 videos here. Our last video will go over our final parts of the chapter and the story problems. So thank you for watching. Send me an email if you have any questions.